Thank you, Farron, for the introduction. I did not ask him to emphasize the on Ohio State, but I appreciate it. That is the correct pronunciation. So today I'm going to talk about pre-stressed concrete bank caps and kind of how they've been used in TxDOT. Let's see. Okay, here we go. Sorry, we're frozen there. So I'm going to start by talking about sort of the predecessor to the pre-stressed bank caps, just very briefly, which are the conventionally reinforced precast caps. I'll then kind of talk about the idea behind why we went to pre-stressed bank caps, and then I want to focus on some of the projects that we've implemented them in since we've used them, and sort of show off some of the successes of it. After that, I'll mention briefly the ongoing research into pre-stressed bank caps that we're working with, and sort of discuss where we see ourselves moving forward with these caps. So in the mid-90s, right around 1994, TxDOT had a number of different construction projects where conventionally cast-in-place concrete caps were not as feasible. This picture right here is US 290 in Austin. This ramp specifically is labeled Ramp G, and you can see the lower roadway there. You have a lot of heavy traffic going through it. It was a pretty important corridor, and this made it very infeasible to shut it down. So their solution was to precast an inverted bank cap and install it. I believe the original, I forget the original numbers, but they were able to cut the construction closure of this lower roadway by a month's time, which is really, really good, not only for construction timelines, but also for public disruptances, or disruptants. Precast concrete, they generally tend to have better concrete quality than cast in place because they're they're made in a prefabrication yard where there's a lot more inspection, a lot more control over the product, and just faster construction, as I mentioned. Generally, if you have sort of a go-by is if you have one team of 5 workers to install either a cast-in-place or a precast, one team of 5 workers can generally cast 3 cast-in-place bank three cast-in-place bank caps in 8 days. But that same team of 5 workers can install 12 precast caps in 1 day. So we're talking order of magnitudes faster. So in about 2014, right about the time I started working with TxDOT, we thought, well, these are a great idea. We love the precast caps. They're very useful. But we're starting to think more about how can we make these perform better. And it's actually pretty good to be after Trenton's presentation on corrosion protection. We thought, how can we help with this? So pre-stressing, it has all the same advantages as the conventionally reinforced precast caps because we're still precasting it in a prefab yard, higher quality control, faster construction. But now we're going to add in these pre-stressing strands, and the theory is that we'll be keeping it crack-free in a number of different stages, from lifting to handling, even service load levels. So to date, the TxDOT Bridge Division, we've worked on 4 separate pre-stressed precast bank cap projects. And they're listed here. The first one we did was Loop 1604 in Bexar County. It's just on the east side of San Antonio, just north of I-10. We also then shortly after did FM 973, which is in Travis County. It's just west of the 130 71 interchange. And 2 more recent projects, Pecos River Bridge in Crane County, which is out there in West Texas. This one is a pretty unique project. I'll get into a little bit more. They really loved precast on that project and did a whole number of different elements. And the most recent project is the Fisher Store Road here in Hayes County in Wimberley, Texas, just south of Austin. So the first project, Loop 1604, Bexar County, San Antonio, Texas. This project originally was designed with conventionally cast-in-place caps. They didn't originally go with precast, but the structures are 2 twin, very long, about almost 2,000-foot long bridges with 18 bank caps per bridge. Based on the geometry they had, each of the bank caps were practically identical. The only real difference is you'll see these large bearing seats. There was a super elevation transition. That was the only major difference. So one of the advantages of precasting is repeatability. If you can have the same thing over and over, the fabricators can do it really, really quickly. So you'll see here this long, long line of bank caps. The first bridge of 18 bank caps, they were able to install all 18 bank caps in 3 days. And I'll point out the only reason it was that slow is because they had to cross a creek. The first day they installed 2. They had to then cross over the nearby creek that was in the way. They installed 14 on the second day and then finished off 2 more on the final day. So very, very fast to install. The second project that then we worked on was FM 973 in over the Colorado River here, in Travis County in Austin. This one, it was again 2 twin structures, a northbound and a southbound bridge, but it was much shorter bridge length, only 4 bents per bridge. Problem here was it's fairly high traffic location, and they didn't want to have the road shut down for an extended period of time. The contractor had a fairly aggressive construction timeline, and they thought, why don't we try to go with precast caps here? I attended this installation of this cap right here, and from the moment the crane picked the cap off of the bed of the truck to the moment they released it on top of the caps only took approximately 15 minutes. So it is very, very fast installation. The only thing that even takes that much time is shimming, and you'll see, if you can see it here, we have these dowel bars that stick out of the column into corresponding ducts in the cap, and it could take a little bit of time to sort of fit those in, but most contractors have said that it generally goes very smoothly, especially if they use a template when installing the substructure and foundations. One thing that they did and that you might want to be careful with that I'll point out, so you can see they have these haul roads that go down pretty steep roads down to the riverbed, and same thing on this one. It was quite a bit steeper on this side. They got their crane stuck down on the bottom of the haul road because of the grade of it. So if you are going to have this sort of access to your bridge, it's a good thing to consider before you get there. You know, how are we going to be able to sort of access the site? The next project out in West Texas, Pecos River Bridge. This construction site was in a very remote location. There were no concrete batches that were within an acceptable range based on the TxDOT limits for how far you can send concrete from batch plant. So they had to figure out how can we install and build this quickly. So they built these precast caps, and this one varied a bit from the first 2 projects. The first 2 project was just the Tex girders, and so you notice they had the large bearing seats at each of the beam locations. This one was a slab beam bridge, so they built actually this little housetop cross slope for it, and where they could set the beams upon. This project, as I mentioned, because of the remoteness of it, they also precasted a number of different elements on this, not just the bank caps. They also did precast abutments that were pre-stressed as well, and they did precast wing walls that I believe they used Dyewood just to keep them locked together, and they even did precast approach slabs, which I don't believe had been done before. Now, this is the most recent project, and I think a lot of people in here will probably recognize these pictures. This was, I believe, during the last year's intense flooding events. This is Fisher Store Road in Wimberley, Texas. It's just south of Austin. This is the bridge after the flood events. It was taken out, superstructure completely off, the substructure heavily damaged, a lot of debris down there. This bridge, one of the major issues with replacing it is the best detour they could do was a 30-mile detour that was roughly 40 minutes of added time for the commuters. So they went in with a pretty aggressive construction timeline as an emergency replacement project. You'll see here it's just 4 bent caps again. It's not a lot, but I believe the installation time of these bent caps was only 10 minutes per bent cap. They were able to install each one of these in 1 day. And it's a similar sort of landscape here to FM 973, pretty significant grades on the haul roads, but they did a good job prior to installing them and didn't actually get their cranes hung up, so they were able to do this very quickly. The overall project was really well done, and from the time of demolishing what I showed you in the first picture on it to the time that they completed the construction was 80 days. So using precast elements and the bents, it really helped speed up their timeline. So each one of those was a one-off design. We did them in-house. We didn't have a standard to work by. So with the last couple of years, we started working on Prestress precast bent cap standard. Now this standard was released to our TxDOT standards website this past April. It is intended as an alternate for our standard bridge interior bents. So that was kind of a wordy sentence. Basically, alternate, the intent is with any of the bridge projects, and I will say any of the standard bridge projects, you can add this in as a standard so that they can still choose to go with cast in place, or they can choose to replace it with a pre-tension bent. It is also only applies to the caps supported upon round columns at this time. We don't have any for the standards for like the trestle bents. And it also, we limited the applicability of these to the text girders, X-beams, box beams, deck slab beams, and slab beams. One of the nice things about this standard is it does not require any adjustments to the quantities. You don't have to worry about calculating quantities for it. It is paid under the same item as the cast-in-place bent cap. And there are no special specifications. Everything you need to know about how to construct it is on the standard or in our current spec book. It's governed by the current, I believe it's item 425, the pre-stressing item. Here's just a look at the first page of it. Up in the right is a table that applies, it shows you which beams the standard applies to, and it also tells you sort of the geometry and pre-stressing needs for each individual bent based on what beam you're using. So we tried to keep it as this standard only applies to each of the current standards for those beam types that we have, but we limited the sheets, to be general for all the standards, so we don't have an interior bent standard for each individual like we do with the cast in place. We also have ongoing research project 6863. It's being conducted here at Texas A&M with TTI. You'll see there that is what a full-scale bent cap test. They've basically cut the bent cap off at an inflection point so as to limit the general size of it, but they're performing full-scale tests, loading this all the way to failure so that we can see how well it performs. And we also tried a number of different details in it. In particular, we varied the amount of pre-stressing to see how effective it is from a low pre-stressing to higher. We also implemented some voids in the section to see how well it performs, while also seeing if we can reduce the weight, because if we can reduce the weight, we can build bigger ones and have more applicability. And we also worked on varying the reinforcing detail, such as shear reinforcing, confinement reinforcing, things like that, seeing if we can be more efficient with our use of steel. And the last thing we did, if you noticed in those other projects, the connection details was dowels from the column. And one of the problems that can happen is the dowel connection needs to be grouted. That's the way it's finally connected. And we've seen sometimes the contractor can have an issue getting proper consistency or workability with their grout. So what we did in this research project, it's actually sort of a continuation of a former NCHRP project. We implemented just a large duct that's roughly the size of the columns reinforcing. So we are moving, the current standard doesn't have any dowels. You simply extend the column reinforcing into the void. This project, what they did is sort of halfway in between that, they have dowels coming out in a smaller pipe connection, which also can help to keep the size of the cap smaller and reduce shipping weights. So moving forward, what do we see in the future? Well, the research project, it's slated to be finished end of this year, so we're looking forward to seeing the results from the project and hopefully implementing their findings and making these caps a little bit more efficient and perform a little better. We also see using some of the findings from the research project and also some of our lessons learned from other construction projects to keep these standards updated. We want to try to make them as good as possible. So we'll try to refine some of the reinforcing details, make it easier on the fabricator. We'll consider the addition of voids into the section so that we can reduce their weights, which can be a controlling factor. And also the revised connection detail, we think, will make it much easier on the contractor, both from a tolerance standpoint, because if you have just the dowels and a pipe, there's over 3 inches generally of tolerance that they can work with. And also, they no longer need to work with the grout. They can simply concrete the connection, which is much simpler for them. Also, we want to increase the awareness of these standards and these bent caps, and so hopefully we can increase the use of these across the state, because we really think they perform pretty well and are really easy for the contractors, and they speed construction up a great deal. I'd like to acknowledge the fabricator for each of these projects, and the research project has been Bear Concrete Works in San Antonio. The individual contractors were Texas Sterling, Lane Construction, Realm Co., and Dan Williams for the noted projects. And again, acknowledge the research team at Texas A&M and TTI for their ongoing work. And that is, that's all I have. Does anybody have a quick question? Yes, sir? So cost is a very difficult thing to get, especially because we don't pay for it based on a separate item. As far as, it's not more expensive. That's basically all we know at this point. So cost hasn't been a factor in not selecting it. But getting the specific cost factors so far, we don't have any of those numbers. I know that is, I believe that's a current option on the conventional precast standard for steel piles. We haven't done that yet for our pre-stress caps. We haven't looked at embed plates. Yes. No, we have not started working on an abutment standard. Yeah, that one abutment project was the only one where they used it. Yes, sir. Mm-hmm. So the grout is subsidiary, and essentially what we're saying is it's just still paid under the same item as the cast in place cap. So while it is a different concrete, we're essentially just telling them we're not considering it any different. So we will pay it the same as a cast in place cap. So based on the current standard, the way this standard works is for your project, when you put in you have to still, it's only an alternate. It is not a standalone standard. So you will already have a cast-in-place standard there, and then you put this in as well. So you should already have a cast-in-place quantity. I think I'll let the next speaker go up. I don't want to take too much time. So if you have any more questions, I'll be available after the session.